Hello everyone, this is Nagan Chaudhary. Today I am going to explain you about closure properties of CFL. Closure properties of CFL. CFL is also known as context-free languages. CFL is a short form. Context-free languages are accepted by push-down automata, but not by the finite automata. Context-free languages can be generated by context-free grammar, which has the form A related to P, where A belongs to N, P belongs to T union N star, and N is a non-terminal and T is terminal. Types of properties of CFL. There are 5 types of properties of CFL. In that, 3 are closed under CFL and 2 are not closed under CFL. And we will see about them. Union, concatenation, clean closure, intersection and complementation. And union, concatenation and clean closure are come under closed property of CFL, and intersection and complementation are not closed under the CFL. While we move to the union, if L1 and L2 are two context-free languages, then L1 union L2 will also be a context-free language. And when we move to the concatenation, if L1 and L2 are two context-free languages, then L1 dot L2 will also be context-free. And clean closure. If L1 is a context-free, its clean closure L1 star will also be a context-free. Intersection, which are not which are not closed under context-free language. If L1 and if L2 are two context-free languages, their intersection L1 and intersection L2 need not to be context-free. For example, L1 equal to some language, L2 equal to some language, L3 equal to L1 intersection L2. This may be a context-free language or may not be. Determinate. And when we move to the complementation of the context-free language L1, which is sigma star minus L1. L1 is a language which we can choose and need not to be a context-free language. And now let us move to the union. Now let us move to the properties of context-free languages. Union. We have seen the context-free languages before, and now we are seeing about union. If L1 and L2 are two context-free languages, their union L1 union L2 will also be a context-free language. For example, let us consider two languages, L1, A power n, B power n, C power m, and m is greater than or equal to 0, and n is greater than or equal to 0 are the condition. And L2 equal to A power n, B power m, C power n, and n is greater than or equal to 0, and m is greater than or equal to 0 are conditions for the languages. When we union these languages, L3, which is denoted by L3 here, equal to L1 union L2. Here, A power n, B power m, C power n union A power n, B power m, C power m, and n is greater than or equal to 0, m is greater than or equal to 0 is the union, which is also a context free. And here L1 says the number of A should be equal to the number of B's, and L2 says the number of B should be equal to the number of C's. Then union says that either of two conditions to be true, so it is also called a context-free language. Now let us move to the another context-free language property, that is concatenation. If L1 and L2 are the two defined languages are the context-free language, their concatenation L1 dot L2 will also be a context-free language. For example, let us consider L1 equal to A power n, B power m, and n is greater than or equal to 0 are the condition, and L2 equal to C power m, D power n, and m is greater than or equal to 0 is the condition. The concatenation of the languages L1 and L2 is defined as L3 here. L1 dot L2 is the form of concatenation equal to A power n, B power m, C power n, D power m, and m is greater than or equal to 0 and n is greater than or equal to 0 is also a context free. And here L1 says A should be equal to number of B's and L2 says C should be equal to number of D's. Their concatenation says first number of A should be equal to number of B's. The number of C should be equal to number of D's. So we can create a PDA which will first push for A's, pop for A's, pop for B's, push for C's, pop for D's. So it can be accepted by push down automata. Hence, it is a context-free language. And now let us move to the another property, that is clean closure or star closure. Let us consider the language L1 is a context free. Its clean closure, that is L1 star, will also be a context free. For example, L1 equal to A power n, B power n, and n is greater than or equal to is the condition, else L1 star equal to A power n, B power n, and n is greater than or equal to 0 whole star is also a context free. And now let us see the another property, intersection. Here let us consider two languages, L1 and L2, which was a context free languages. Their intersection L1 intersection L2 need not be a context free compulsorily. For example, L1 equal to A power n, B power m, C power m, and n is greater than or equal to 0, m is greater than or equal to 0. L2 equal to A power m, B power n, C power n is greater than or equal to 0, and m is greater than or equal to 0. L3 equal to L1 intersection L2, which is equal to A power n, B power n, C power n is greater than or equal to 0, need not to be context free. Here L1 says that number of A should be equal to number of B's, and L2 says that number of B should be equal to number of C's. Their intersection says that both conditions need to be true. But push down automata can compare only two, so it cannot be accepted by push down automata. Hence, it's not a context free. Similarly, the complementation of context free language L1 which is equal to sigma star minus L1 need not to be a context free. Now let us discuss about deterministic context-free languages. Deterministic context-free languages are subset of context-free languages, that is CFL, which we have seen before, which can be recognized by deterministic push-down automata. And deterministic push-down automata has only one move from the given state and input symbol. That is, it does not have choice for a language to be deterministic context-free language. It should be clear when to push or when to pop. For example, let us consider L1 equal to A power n, B power n, C power n, and m is greater than or equal to 0 and n is greater than or equal to 0 are the conditions for the language 1. And let us consider another language L3, and here the language equal to A power n, B power n, C power m union A power n, B power m, C power m, and here n is greater than or equal to 0, m is greater than or equal to 0. These are the two languages which we consider, and this is the first language L1 is the deterministic context free language, because for A's we can push on stack and for B's we can pop from the stack. It can be recognized by deterministic PDA, that is push down automata. And when we see the language 3, and it is having A power n, B power m, C power n union A power n, B power m, C power m, and n is greater than 0 and m is greater than 0, which we have discussed, and cannot be recognized by DPDA because either number of A's and B's can be equal or either of number of B's and C's can be equal, and so it can only implemented in NPDA. Thus, it is CLF but not DCLF. Note, DCLF are closed only under complementation or inverse homomorphism. And now let us see an example problem. Question. The language L equal to 0 power I, 1, 2 power I, and I greater than or equal to 0 over the alphabet 0, 1, 2 is a not recursive, is recursive and deterministic CFL, is regular, or is CFL but not deterministic. We need to choose an option for this. And when we come to the solution, the above language is deterministic. CFL. As for zeros, we can push 0 on stack, and for 2's we can pop correspondingly zeros. As there is no ambiguity which moves to take, it is deterministic. So correct option is B. And while we come to the recursive part, as CFL is a subset of recursive, it is a recursive as well. So the option is B. Thank you. I hope you got something from here.